All right, we're going to wrap up our unit on right triangles and similarity as we talk about the law of sines and cosines. This is some special form of trig that we can use on triangles that are not right triangles. So first of all, the law of sines. On your notes, you should have an explanation of the law of sines. But it tells us that right triangle trigonometry is used to solve right triangles, which we've learned already. But there are many problems that can be solved that don't use right triangles. So we'll use right triangle trigonometry to develop what's known as the law of sines. And we'll apply that as we go through here. So here's the law of sines. Sine of A over A equals sine of B over B equals sine of C over C. And we've got a triangle that references that. So here's how it works. So triangle ABC doesn't have a right angle. So we take triangle ABC and we draw this line here. And we call it a perpendicular line from vertex B. So this would be the altitude. So when we draw that altitude, we have multiple triangles in here, multiple right triangles. So let's start off by taking the sine of A. So if we take the sine of A, that's opposite over hypotenuse, so H over C. And if we multiply both sides by C, we get H equal to C times the sine of A. We can do the same thing with angle C. Take the sine of C, so opposite over hypotenuse, so H over A. Multiply both sides by A, and we'd get H equals A times the sine of C. So notice we have H solved in both of these. So these would be equal by the reflexive property, or sorry, the transitive property. So since H is equal to C times the sine of A and H is also equal to A times the sine of C, we can say that C sine of A equals A times the sine of C, since they're both equal to H. They have to be the same. So now we can simplify those. I can divide this side by C, divide both sides by C. I can divide this side by A to cancel out A on this side. Divide both sides by A, and I'll end up with sine of A over A equals sine of C over C. Okay, so now we can take the altitude from A down to its opposite side and do the same thing. So if I'm looking at angle B, opposite over hypotenuse, so K over C, multiply both sides by C, I've got K equal to C times the sine of angle B. Look at angle C, since this is a right triangle, opposite over hypotenuse, so K over B. Multiply both sides by B, I get K equal to B times the sine of C. Transitive property states that if K is equal to both of these, they're going to be equal to each other. So C times the sine of B equals B times the sine of C. And we can solve both those, divide both sides by C, and divide both sides by B. And I get sine of B over B equals sine of C over C. So since they're all equal to each other, and we get the law of sines, which would be true for any triangle, since we can divide any triangle into a right triangle however we wanted to. Okay, next we talk about the law of cosines. Law of sines and law of cosines both deal with non-right triangles. The law of sines helps us to find measures of missing angles and sides, the measures of two angles and a side, or the measures of two sides and non-included angle are known. However, the law of sines cannot be used to determine the measures of missing angles and sides of triangles. The measures of two sides and an included angle, or the measures of three sides, are known. Since the law of sines can only be used in those certain situations, we need another method, and so this method is known as the law of cosines. Same, we have a triangle with angles A, B, and C, opposite sides A, B, and C, and we come up with this equation: A squared equals B squared plus C squared minus 2BC cosine of A. And the same for B squared and C squared. So this one, if we want to take a look at why this one works, we start off with triangle ABC, which doesn't have a right angle, so we draw the altitude in again from vertex B. So we can see that sine of A equals opposite over hypotenuse, so H over C Multiply both sides by c again, so we get h equals c times the sine of a. And if we take the cosine of a, so here we'll be looking at the adjacent side. So since this whole length is b, we'll just call this one r for now. Adjacent over hypotenuse, so r over c. Multiply both those sides by c, and I get r equal to c times the cosine of a. Okay, so now let's take a look at triangle CBD. And in triangle CBD, we've got a right angle, so we can use the Pythagorean theorem there. So h squared plus b minus r squared, so what do we have left here, would equal a squared, using that Pythagorean theorem relationship. We can substitute for h and r, since we've solved for h and r up here. So h is c times the sine of a squared, plus, in parentheses, b minus r, c cosine of a squared. Okay, so we substitute those parts in, and now we just simplify this algebraically. So c sine of a squared becomes c squared sine squared of a, plus when we multiply out b minus c cosine of a, we get b squared, because this really, if you remember from algebra, b minus c cosine of a, and we're multiplying by itself. So first term squared, and then we're multiplying, doubling these, 2 times b c cosine a, and then we square the last term, c squared cosine squared of a. Next we can factor. Since I have this term and this term here, I really have 4 terms. I see that 2 of these terms contain c squared. So I can factor out a c squared from those terms. And what am I left with? Sine squared a plus cosine squared a. So that's how we get that first part. And we just rearrange. So plus b squared minus 2bc cosine of a. And you haven't learned this yet, but trig identity states that sine squared plus cosine squared is 1. So we can simplify that down. And so c squared times 1 is just c squared. So we finish up with c squared plus b squared minus 2bc cosine of a equals a squared. Seems like a complicated equation, but once we start using it, we'll see how helpful it is. We can follow that same process to find the other variables for b squared and c squared. I won't show you that process, but just have to trust that it works out. So that's the law of cosines. And as long as we know a couple of sides at an angle, or all 3 sides, we can figure out the other missing parts by solving the equation. So let's take a look at how we can apply the law of sines. So we want to figure out how much closer we live to the music store than our friend does. So we need to find out b and a. So let's set up what we know. So sine of a over a. So sine of 81 over a equals sine of b, which is 65 degrees, over b, which we don't know either, equals sine c, 34 over 1.5. And then once we set up our equation, notice we've got multiple proportions here, let's figure out which one we want to solve first. So let's solve for b first of all. So in order to solve for b, I can use cross products. So 1.5 times the sine of 65 will be equal to b times the sine of 64. And if I want to get b by itself, notice I can just divide by the sine of 34. So b will be equal to 1.5 times the sine of 65, and all that divided by the sine of 34 rather. So here's where it would be helpful to use my calculator. So once I have it all written out here, I'll just take my expression and put it into my calculator so I can solve for b. So we had 1.5 times the sine of, what was that, 65? And we're going to divide that by the sine of 34. And we get a value of 2.4. So B will be about 2.4. And what are we measuring in miles? So 2.4 miles. So now why don't you try solving for A and see what you get. Okay, so I took sine of 81 over A and compared it to sine of 34 over 1.5. You could have compared it with our value for B, 2.4, if you wanted to. So I did cross products 1.5 times sine of 81 equals A times sine of 34. Divided both sides by the sine of 34, and when I calculated that, I got 2.6 miles. So A is 2.6 and B is 2.4. Question asks, how much closer do you live to the music store? So I live 0.2 miles closer than my friend. So you see how we can apply that law of sines. Notice when we have all three angles in one of the sides. We need to have at least, one of the information so that we can compare. So we got to have either all three angles in a side, or one of the other cases, two angles and a side. But if we just know all the angles or all the sides, we have nothing to compare in our ratios. So we're going to have to use the law of cosines for that case. So in this case, we're going to use the law of cosines because we just know all three sides of a triangle. That A is 11, B is 17, and C is 19. So we want to find measure of angle C. So we're going to have to use law of cosines. So we have to figure out which formula we want to use. So since I want to find measure of angle C, the only one that uses that is this one down here. So I'm going to fill in the blanks. So C squared. It's always one opposite from C. So let's say this was called angle D. We would call this one D squared. So this will be 19 squared equal to A squared, 11 squared, plus B squared minus 2 times A, which is 11, times B, 17, times cosine of C, which we don't know yet. So we're going to simplify this down as much as we can. So 19 squared is 361. 11 squared is 121. 17 squared is 289. And minus 2 times 11 times 17 gives me negative 374 times the cosine of C. So we want to solve for C, so we need to get that all alone. So we can combine 121 and 289 to give us, let's see, 410 equals 361. So 410 minus 374 times the cosine of C. So we'll subtract 410 from both sides. So 361 minus 410 gives us negative 49. And that's equal to negative 374 times the cosine of C. At this point, we need to divide by negative 374 in order to get the cosine of C by itself. So negative 49 divided by negative 374 gives us 0.13 approximately. So now in order to solve for C, we need to remove cosine from this side of the equation. So we'll need to do the cosine inverse. So the cosine inverse of 0.13, and that'll give us the value of the angle of C. So I can go to my calculator and take the cosine inverse of 0.13, and that is about 82.5 degrees. So it would be roughly angle C be about 82.5 degrees. And that's how we use the law of cosines. So the law of cosines and the law of sines are two equations that we can use in non-right triangles to figure out missing sides or angles.